Here we are with this mathematics level test 1, the easy difficulty level, to really give you an introduction to the topics that are going to be in the 2024-2025 mathematics subject. So, number 1, in how many ways can 8 paintings be arranged on the wall? Key thing right here is arranged. When you are arranging something, it means you're putting it in order. So if you imagine these things right here, 3, 4, 5, 6, 7, 8. There's the wall right there. How many how many paintings can we put in this first one? And that's an 8. And then if we've used one, we have 7 options here. Now, if you have this list of place values and then you have so many options in each one of them, it is multiplication that goes between those. It gives you how many different options. So imagine we had 8 different guys here and 7 there. That gives us 56 different mixing and matchings of the first 2. Now we've just used 2 of them, so we got 6 left. 5, 4, 3, 2, 1. So we take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because this happens so often, and you'll notice it's like how many different ways could 9 paintings be arranged on a wall? We'd have 9, 8, 7, 6 all the way down to 1. This is a very common term in probability and counting, and this is called 8 factorial. Factorial is when you start with the number and go all the way down to 1. So let's see where that happens on a calculator. So here, you see I already did it once, but let's go through the process. 8, and then we have math, go over to the probability, go down to the factorial button, or you could just hit a 4 and you'll see 8 factorial. That's an exclamation point. Hit enter and it is 40,320 right there. Good. Number 2, what is an arrangement of objects from a group where no object can be used more than once and the order of selection matters? Now notice that this order matters. This is called an ordering and it's an arrangement. Those are keywords that means like on this 8 paintings being arranged on the wall, if you switch 2 places, that matters. And this right up here that we used, a factorial, this is a permutation. Now this is in contrast to a combination. A combination is when it's a set of objects or a group of objects. Now, you may say, what about this factorial that we just had, or the multiplication? The multiplication principle is that when you have these slots that you're filling, you're going to multiply between them. That's good. Factorial notation, you'll notice we use factorial. Now, if I said how many ways, if we have 8 paintings, can we arrange 4 of them on a wall, I wouldn't have gone all the way down to 1. So I wouldn't have used that factorial right there. So factorial is very handy and it comes into use with permutations, but a permutation is saying it is an arrangement of objects. So how many permutations do we get of these 8 paintings? And we used factorial notation to say it, but the vocabulary word is permutation. Okay, number 3. In how many different ways can a set of 5 books be selected from a group of 8 books? Now notice, this is a set, this is a group, this is not an arrangement or ordering, so it will not be a permutation. This is actually going to be, I'm going to circle this guy, that's a combination. And we write it as 8 choose 5. So it's a combination, the letter C is used, and this is how it works. You start out with 8 factorial, and you divide it by 5 factorial, and you divide it by 3 factorial. Now, that's the formula for combinations. And it really says, what if we had all of them, but hey, we only want the first 5, so that's why we got rid of these 3 over here. And then talking about groups, we then divided off how many different ways those 5 books could be arranged by themselves, which again refers to the factorial notation. And so we're going to punch this in. So a couple of different ways to do this. We would take 8 probability, and let's do the factorial there. 8 factorial, enter, and then we divide that by 5 factorial times 3 factorial. 5 math factorial times 3 factorial. Let's punch that guy in right there. That, and boom, like that. And we enter it, and it turns out to be 56. So 56 is indeed the answer. Now, you can actually do these smaller numbers by hand. We could have done 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Oh my goodness, there's a 5 factorial right there. And 3 times 2 times 1. Notice this 5 factorial will just cancel. And so, and 3 and 2 cancel with the 6. And so we're left with 8 times 7, which is 56. The calculator probably processed that whole thing, but that is these factorials often will cancel in a very nice way. All right, number 4. This one is one we're going to take out a loan for $450 at a monthly interest rate of 2%. Whoa, that's kicking it. How much will you owe at the end of 6 months, assuming no payments have been made? So we're just going to have this 450 and it's going to grow at a monthly interest rate for 2% each month. That's crazy. So this is a calculator one where we're going to, let's clear what we did before. Good. And there is an app, in this case, on this calculator, it's a finance app. And this is what you need to know. And this is the time value money solver. That is your friend. Time value money solver. Let's clear all of these out so you can kind of see what is going on here. So N, this is the number of periods, which in this case is 6. So N equals 6. Let's start this. This is going to be the principal or the principal value. It'll be either a P or a PV in formulas. The interest rate here is the interest rate for this period, which is very important. So this is the monthly interest rate of 2%. Okay. And then at the end of 6 months. So let's go back to this and you'll notice. So this is N, which is 6. And the interest rate, which is 2%. And then this guy right here is how much money was given to us, which was $450 right there. Good. And then there's no payment. Good. And the final value, that's what we're going to do. Now, this one, this is payments per year. And so we have to be very cautious about this. In fact, we need to go back up and fix something. If it is 2% per month, then that is 24% per year. If there are 12 payments or 12 cycles of interest per year. And so we need to go now down to this final value. And this is what we want to solve for. So this guy right here, this we delete all those off. This is how you use this solver. You fill in everything you have, and then you hit alpha solve. It's alpha enter. And so it's 506.77. Now this is how much money has to leave your hand to pay this off. That's how the negatives and positives work in this. If money comes towards your pocket, it's a positive, and if it leaves, that means or negative, that means it leaves. So this is 506.77 right there. Okay. Now notice if it's a monthly interest rate, that means a yearly interest rate of 12%. That's going to be sorry, not 12%, 24%. Because that times 12. So that's interesting. When you're using the calculator, you have to use the yearly interest rate. The APR is that percent. Okay, good. Okay, let's move on to number 5. You're organizing a summer music festival in your town. There are 4 bands that want to play. Okay, so this is going to be a combination or a permutation. Let's look at it. 4 bands that want to play, but you only have time for 2 bands to play. And a band should not play twice if the order of the performance matters. So the order of the performance matters. That means we're dealing with a permutation, not a combination. How many different concerts can you put on? So this is going to be 4, and it's a permutation of 2 because the order matters. So this is going to be 4 factorial over how many we don't want, 2 factorial, which is going to be 4 factorial. Whoops. Rewrite that. 4 times 3 times 2 times 1 over 2 times 1. So that cancels with that. 4 times 3 is a 12. So we get 12 right there. Now, you actually could have done this. If you have bands A, B, C, and D, you could have been like, okay, we could do band A, B, A, C, A, D, or B, let me see, B, C, or B, D, or C, D. And then a different concert would be Again, order of performance matters. This is 6 of them that takes in all different combinations. And if you switch them places, BA would be a different concert, CA would be a different concert anyway, and you can actually identify by brute force that there were 12 of them. Okay, so number 6, this is going to be a polynomial. Find the sum right here, which means these are polynomials. We're going to combine like terms. So 2x to the 5th, there's no other x to the 5th. So we're going to have a 2x to the 5th, and no other x cubed. So we're going to have a minus 4x cubed. Okay, then 3x squared and 8x squared, that makes 11x squared. And you'll notice it has to be C right there. That's the only one that has the 11x squared. And then, of course, the negative 5 and the plus 1 make a minus 4. Good. Yeah, and adding polynomials, you're just combining like terms is all that's happening there. Okay, next one. Number 7. Let's see what we got here. Ooh, this is a binomial expansion, and it takes a little bit to do right here. What is the coefficient of x to the 4th in the term of this expansion? Now, I'm going to write out the expansion formula, a plus b to the nth power, and this is like for the kth term. So when we have an a to the k, b to the n minus k, this right here is n choose k, or what we wrote before was n choose k, or let's write it out, n k factorial n minus k factorial. Okay, so that's, and we sum all those up. That's how you would expand this formula. So in this case right here, we're going to have an x to the 8th, and we're trying to get an x to the 4th. So that means if x is a, let's write this out. In this formula, a, we're going to let that be x, and so we want k to be 4, and then n is 8, and b is 2. So let's write out and see what we have. We have 8 choose 2, x, I just messed that up. 8 choose 4, there we go, 8 choose 4, x to the 4th, 2 to the 8 minus 4. Okay, can you see that right there? That's the sum of those terms. So here we get 8 factorial over 4 factorial, times x to the 4th times 2 to the 4th power. So we're looking for the coefficient on x to the 4th. So this will be, let's simplify this just a little bit. 8 times 5 times, not 8 times 5, times 7 times 6 times 5 times 4 factorial over 4 factorial, and 4 factorial is 3 times 2 times 1, so the 4 factorials cancel. The 4 times 2 is an 8, and a 3 divided into that 6 is a 2. So we get 5 times 2 is 10, times 7 is 70. 70 times x to the 4th times 2 to the 4th is 16. 70 times 16 is 112. 7 times 16 is 112. Let's just double check that with the trusty handy dandy calculator. We're going to do exit out of that. 70 times 16, enter, and that's 1120 right there. So this is 1120 x to the 4th. That's what we got right there. That's the coefficient. Number 7 is B. All right, number 8. You invest $400 at 6% interest per month. How much will you have after 1 month? This is one, let's do the time value of money, but really we're going to take 400 and we're going to add to that 400 times 6%. So we can actually do this one by hand, but we'll go in and do it on the calculator as well so you can see. So this right here would be $24, and 400 plus 24, that's 424. 8 is D. Let's go ahead and plug that into the calculator so you can see. Get the apps, go back to Finance, TVM Solver. So the number of periods is 1. The interest rate, this is per month. That means you have a 72% interest per year. Again, 6 times 12. When you do the calculator, you are doing the annual interest rate. So in this case, it's a 72% interest per year. The principal value is 400. The payment, there's no additional payment being made. The final value at the end, I should note this. When you invest money, it is going away from your pocket. So an investment is negative there, and then it will, oops, sorry about that. Let's quit that guy, go back into the finance, get that guy back out. Okay, TVM solver. Okay, so 72% interest. It is a negative 400. And then there's no payment. And then the final value, this is kind of cool. This is going to come back to you at the end of the investment. Oh, and there are, 12 months in a year. That's right. That's how many payments or cycles we're going to deal. We're going to deal with months. And so alpha solve. And 424 is the final value. And you can tell by this little square dot that it is solved it for you. Okay, next one, number 9. Find the sum of the arithmetic series. That's an important thing to see. Arithmetic, that means it has the same addition. So this would be 11 plus 17, that's addition of 6. So then plus 23 plus 29 plus 35 plus 41. And you could just add those up. But I'm going to show you the trick on how you're supposed to do it. Notice there's 1, 2, 3, 4, 5, 6 of these. These two add up to the same number, 52, as these guys do. Notice I went up 6 and down 6 to get that. So that's another 52, and that's another 52. There were 6 numbers. That means there were 3 pairs that added up to 52. So times by 3, 52 times 3 is 156. So number 9 is going to be E. Okay, we're going to run across this with arithmetic series. You take the first guy and the last guy and then add it up by how many pairs there are, and that's going to be your formula for adding those up. That's kind of fun. So number 10. What type of sequence has a constant ratio? That's important. So this one had a common difference. Added 6, added 6, added 6. This one would be if it times by 2, times by 2, times by 2. It is called a geometric. And that's just a vocabulary question right there. Geometric has a common ratio. And an arithmetic has a common, it's called a common difference. It's like a common set amount, but a common difference. Good deal. Let's go on to the next one. Number 11. Okay, so here, find the sum. That's what this means. We're going to put plus signs in between. We're going to stick 4 into k. So we're going to take 4 squared plus, do the next number, 5 squared, up to this upper number, which is 6 squared. So this one was actually not so tough. This is 16 plus 25. It's making sure you know what this means. That means sum, which means plus signs in between each of the terms. And you just stick, this should have had a k right there. You stick that the k starts at 4 and it goes up to 6. Minimum, maximum value. 16 plus 25 plus 36. 16 plus 25 is 41 plus 36 is 77. Okay, number 12. What is the next term in the sequence? This is 1, 1/2, 1/4, 1/8. As you can tell, they're dividing by 2 each time, which means they're timesing by 1/2. Times by 1/2 times by 1/2. So we're going to get 1/16 right here. As a reminder of the previous one, this has a constant ratio of 1/2. So this is called a geometric series. And that's important to note. So 1/16, but recognizing this is a geometric series is important. Okay, number 13. Oh, looks like we're going to use a calculator again. Let's make sure we identify stuff. So here you make an investment. So that's PV, principal value, and this is going to be negative. Why? Because it's going away from your hands. With interest compounded, yearly. When we get to payments per year or cycles, compoundings per year, this is going to be 1, not a 12. We're not doing it monthly. We're doing it annually. Annual interest rate, so this is going to be the interest rate percent. How much is your investment into the worth of 9 compounding periods, 9 years in this case. So n is going to be 9. So let's punch all those guys in. Oh, look, we're still there. That's good. So 9, interest rate is 6% at principal value is negative 5,200. Again, because it's an investment. Oops, I just did 52. There we go, 5,200. We're not making additional payments, but you can tell when you have to put that in, it make it much more tough. And then the final value is what we're solving for, but the payments per year, compoundings per year, if you just change the payments per year, it'll automatically change there you go. And final value, alpha, solve, 87, 85, 29. Oh my goodness, look, how handy is that? It was right there. Now, I do want to show you that 5,200, if you don't have a payment, you actually don't have to use the calculator in that manner. You could say, oh, it is itself plus 6% of itself, and that happens 9 times. So you times it by 1.06 9 times, and let's show you that that comes out to be exactly the same. Second quit out of here, and we take 5,200 times 1.06 to the 9th power. And 87, 85, 29. Exactly right on. Excellent. Okay. Let's go to number 14. Notice here's an expansion again, all to the 6th power. And I'm going to write out what the expansion is. A plus B, all to the nth power. And again, you sum up these individual terms, but it is n choose k. You remember that is the same thing as writing n choose k, like that. And a to the k and b to the n minus k. All right, and then you sum all of those up where k goes from 0 up to n. All right, so we're going to expand this guy out. Oh, wow, and it looks like, well, that guy's not going to be it. You wish. That's called the freshman's dream if you just do that. But you'll notice that we're going to have a difference by the time we get to the third one. So let's start computing this. So first of all, if k is, let's do the first one, 6th power. So we'll start at n is 6. We should write that down. N equals 6. K is going to move up and down all the way from 6 all the way down to 0 or 0 up there. And then what B is 3. And K, okay, yeah, good. So if we do this, let's let K equal 6. Let's start at 6. We'll start at the top and go down because they're starting at the highest power. So the first term would be 6 choose 6. A to the 6th, not A, we're doing an X. Oh, huh, A equals X. Good. So X to the 6th, B to the 0. So 6 choose 6, that's 6 factorial over 6 factorial, 0 factorial, which gives you 1, X to the 6th, B. Yeah, so right now that, and that are all good options. E is out. Now, the reason I X'd out that one is, yeah, there are going to be middle terms here. So let's let K equal 5 now. So we get, the next one is 6 choose 5, X to the 5th. B, what is B? B is 3 to the 1st power. And so let's do this. 6 factorial over 5 factorial, 1 factorial. 6 factorial is 6 times 5 factorial. Those cancel, so we get 6. X to the 5th, 3 to the 1st, which is 18x to the 5th. So that means this guy's out. And yeah, and that guy's out. So that guy's out and that guy's out. So you'll notice both of these start so far so good. And so we're going to see on the next one what the real is. And so let's do this in a different color, the distinction between these two as we're expanding it out. So as k is, what are we looking for? The 4th term. So if k is 4, then let's write this over here. If k equals 4, then we get 6, choose 4, times a to the 4th, 3 to the 2nd power. That's 6 minus 4. So 6 factorial over 4 factorial, 2 factorial. And again, this is 6 times 5 times 4 factorial. 4 factorials cancel. 2 cancels with the 6 and leaves a 3. 3 times 5 is 15. A to the 4th times 3 squared is 9. 15 times 9 is 135. A, that should be my x, duh. I knew that. 135 x to the 4th power, which is right there. So number 14 is A. We'll teach you a little bit of a shortcut on this binomial. It's called Pascal's triangle. So these coefficients that show up, that's a lot of work. And especially for these, you guys should know the coefficients that pop up. It's called Pascal's triangle, and I'll show it to you over here. Start with a 1, then do a 1 and a 1, and then do a 1 and add these two together, and that's a 1, 2, 1. Okay, then put a 1 out here, add those two together, that's a 3. Add those two together, that's a 3. Add that, and that's a 1. And then a 1 and a 4. 3 plus 3 is 6. 3 plus 1 is 4. And a 1. And so do it again. 1, 5, 10, 10, 5, 1. And then do the next one. 1, 6, 15, 20, 15, 6, 1. Now I want you to notice this 15, well, all of these actually, we got a 1 here, then we got a 6, then we got a 15. These are the coefficients that would do this. So I'm going to write this out so you can see with Pascal's triangle what it would have been if I had used this. So 1, 6, 15, 20, 15, 6, can't quite see it, and then a 1. So 1, x to the 6th, 3 to the 0, plus 6, x to the 5th, 3 to the 1, plus 15, x to the 4th, 3 squared. See how these x's just go down one thing, and the b, whatever, if it was a b, it would just be b to this power, but this happens to be a 3, plus 20, x to the 3rd, 3 to the 3rd, plus 15, x squared, 3 to the 4th, plus 6x, 3 to the 5th, plus 1, x to the 0, 3 to the 6th. And so this actually turns out, if you compute this out, we get 1 x to the 6th, plus 6 times 3 is 18 x to the 5th, plus 15 times 9 is 135 x to the 4th, plus 3 cubed is 27 times 20, that's 540 x cubed, plus 15 times 3 to the 4th, that's 15 times 81 is 1215 x squared, plus 6 times 3 to the 5th, 3 to the 5th is 243 times 6 is going to be 1458. And then plus 3 to the 6th, that's 729. And it actually gives you the whole thing right there. So Pascal's triangle might be beneficial. Now here it expected the whole expansion. In the previous problems, it only wanted one term. So this might be a quicker one, or being able to crash out that Pascal's triangle might be a little bit faster. Okay, number 15, let's move on. How much would you need to invest? So notice the question is PV. That's our question mark. This is our FV. At the end of 5 years, and interest is compounded annually. That means C per Y is a 1 at a rate of 6%. That's our annual interest rate. So we get a calculator on this guy. Let's punch it in. So let's get back to the finance application here. TVM solver. Good. And interest rate, 6%. Nope, sorry. At the end of 5 years, number of periods is 5. Now, this n is the number of compounding periods. So if we were compounding monthly, we'd put a 60 in here for that. Interest rate is 6%. Good. Principal value, we don't know. I'm going to clear that guy. But we do know that the the principal value, we don't know. The payment is a 0. And the final value is $3,000. And that is positive. It's coming out to us. So our answer, our principal value, is going to be negative because it's going away from us. And we're already at 1 compounding per year. So go up to principal value, hit alpha, solve, and we get 2241.77. Boom. Number 15 is E. Great. Number 16. What is the variance? Now, on this guy right here, the variance is like the standard deviation squared. So we're going to use our calculator to punch this in. So here we go. The variance, we're going to do our stats. And we're going to do edit first to get a list in there. It looks like. Alrighty. Okay. Oh, we just delete them. There we go. Okay, so we're going to put this list in. We got a 79, and then we got an 80, and then 89, 87, 87. Okay, so it is now entered into list 1. So let's go back and hit the stats, and now we're going to do a calculation, and we're going to run the one variable statistics on L1, which is this yellow right here. So we have to hit second 1. We're going to run the one variable statistics on that list 1. And notice it's going to put in the average, which is 84.4. That's the mean. Here is the standard deviation right here. 4.07 right here. And so we need to take that number and square it. But notice it also gives us how many there were. That's the sample size, and the minimum and the maximum, and the first quartile and the third quartile, and everything like that. So we need to take 4.079 and square it. Second quit. 4.0792 squared, and we get 16.6364. Oh, there we are. 16.6. Number 17. Here we have the 100th term in this sequence. We have 35, 29, 23. Can you see that it's going to subtract 6 each time? Subtract 6 each time. And notice we subtracted 6 once to get the second term. And then we subtracted 6 again to get the third term. So we're going to subtract 6 99 times. We're going to take 35 and we're going to subtract 6 99 times. And this will get us the 100th term. So let's punch that in really quick. We're going to take 35 minus 6 times 99. And negative 559 right there. Number 17. That's an A. Again, this is an arithmetic sequence, and you can use this to exploit it, that it has this common difference each time. Okay, number 18, a decimal approximation of Euler's constant. Okay, Euler's constant is this E, if you haven't seen it before. If you're not familiar with what E is, there's a trick you can do to get it and just say, hey, on my calculator, I know I have an E to the X button right there. And just say, I want that number to its first power. Let's see what it is. That's it right there. There's Euler's constant. It's kind of as valuable as pi. Pi is 3.1415. It's a number that we use this because its decimal goes on forever and ever. So 2.71828. That pattern does not continue, by the way. All right, so the first 18 smallest positive multiples of 6. So that would be 6 plus 12 plus 18 plus ... plus all the way up to 6 times 18. 18. So what is that, 108? That would be the highest one. And then below that would be 102. So like this. Now you can tell because we go up by 6 each time. Yeah, we can do this. There are 18 of these. That means there's 6 plus 108 is 114. And 12 plus 102 is 114. And since there are 18 numbers, there are 9 of those 114s, which is going to be 1026, I think. Multiplying that out, let's just double check. 9 times 14 is indeed 9 times 114. 9 times 114. There we go. Add 900 to that. There we are. And 19 gives you A. Excellent. Number 20. The median of the set of data is the value with blank number of data points above and below. So if you have a bunch of data in order, the median is the guy right in the middle. And so that is 1/2 of the number is up here, 1/2 of it is below. Half of the data above as below. So, sorry, half is above and half is below. So if it says the blank of data points above as below the line, so the same number. Yeah, same, this guy and that guy, same number of data points above and below. Okay, what value in a data set is the value that occurs most frequently? That is not the median. The median may not actually happen. It just needs to be in the middle and have the same number above and below it. So most frequently, that is a mode. That's what that is called. So the mode. Okay, number 22. We got to find the range. Now the range is the minimum all the way up to the maximum. That is the range. But we don't know if the maximum is 10. This range could be 9. The answer might be B, but I don't know if X is bigger or less, but it says the mean is 5. Now the mean is when you take 1 plus 3 plus 8 plus 10 plus X, divide it all by how many there are, 1, 2, 3, 4, 5 of them, and we end up with 5. That means they have to add up to, their sum has to be 25 to divide by 5, so you can get 5. So what do we have? 10 plus 8 is 18, 21, 24, 2, right? Does that add up to 22? Yeah, it's 22 plus X has to equal 25. So X must be a 3. So this mean of 5, that's what told us that that the average of all these numbers, and we deduced blah, 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 got that X was a 3. That means the minimum is 1, and the max is indeed the 10. So we do have B is the range. Good. Let's do on 23. Let's see what we got here. Oh, this is good. Notice that when we did this one variable statistics, do you remember what came out of here? It had the average and the standard deviation, and then it had these numbers. It's called a 5-number summary, where you have the minimum of them, the maximum of them. The range would then be between those two, and the median was one right in the middle, and then Q1 and Q3. Those are the quartiles. So if this is like the 50% line of all the data, that's like the first quarter, which is 25% line. That's like the 75%. It's kind of the median of the top half and the median of the bottom half. Well, that's what it does. The lower quartile or first quartile is abbreviated Q1. And you can see that on the calculator when it spits it out for you. Okay. So data points that are further than how many times the IQ are. So if you have a bunch of data here and one way out here, so here's the median, and then right there's the Q1, and there's the there's the Q1, and there's the Q3, and you look at this, this is called the inner quartile range. That's kind of the IQR. If this guy is more than 1.5 IQRs off of the max, or below the upper quartile, if you go 1.5 times that, this guy is known as an outlier. So 1.5. And that's just kind of a vocabulary thing. All right. So number 25. A team of 7 is to be chosen from 10 men and 12 women. What is the probability that the team has no men? So you've got to choose a team of 7 from 10 men and 12 women. This one's a little bit tough. Take some thinking. So probability is the part. So this would be that no men are on the team. And this would be how many total possibilities of teams. So here, this one's kind of nice because we have 22 people and we're taking a team of 7. So this is 22, choose 7. That's our denominator right there. Let's go ahead and punch that into the calculator. Quit that guy. Okay, so 22 math. Oh, I don't think I showed you this before. But in probability, you can just do NCR 7. And that is the same thing as 22 math probability divided by, and let me see, how did we write that? 22 factorial over 7 factorial, 15 factorial. Okay, so that's how you count up 22 choose 7 very, very quickly. And so 22 factorial over 7 math 4 times 15. Good. And so, which is that. And look, they're the same number. Oh my goodness. So yes, the nice thing about that right there is it's an automatic way of doing that whole computation. Okay, so on the bottom here we have 17544. 170,544. So that means if you took all the names of all the women and all the men and wrote out all the different teams that could be chosen. Notice these are not orderings, these are teams, groups, which is why we're doing combinations. There would be 170,544 total teams. Now, how many can you make out of just the 12 women in the 7 slots? And that would be 12 choose 7. That's how many there would be if there were only the women to choose from. So let's go ahead and punch that in, and we'll do it the nice easy way with the 12 math probability choose, that's 3, NCR 7, at 792. So we have 792 that are just the women. That's how many different ways you can get 7 groups of women. So that's not going to be a huge probability, but now we have it. There are 792 teams with just women on them, divided by 170,544, and we're at 0.0046. That's 0.005. Booyah. Okay, number 26. Find the standard deviation for the set 1, 3, 7, 8, 11. And this is a calculator again. We're going to go into stats. Let's edit that list. And we are at 1, 3, 7, 8, 11. And good. So there's those 5 things. Go back to the statistics. We're going to run a calculation. Again, the one variable statistics on, you guessed it, L1. And that gives us the average is 6. The standard deviation is 3.6. So you'll look at this sigma, sigma x. That's the standard deviation we've used. And it's going to be 3.57, which is 3.6. Okay, number 27. Oh, got to scroll down just a little bit. Number 27. So now we're going to find the median of this set. Now, you could use this thing right here. And let's do stats, edit, and let's put that list in. 0, 3, 5, 7, 5. Good. And then do stats, run a calculation, one variable statistic on that list 1. And right there, scrolling down, notice it says the median is 5. Booyah. Or if it said the first quartile, you could, in the third quartile, you could also get those, or the interquartile range would be 4.5 in the min and the max, and the range would be 7. But this is a small enough data set, you can do this by hand. If you set this up 0, 3, 5, 5, 7, like this, in order, notice, cut it right down the middle. So you got 2 below and 2 above. That is the median. 27 is E. And so 28, find the mean of the data set. Now the mean is not the same as median. This one, mean means average. So in this case, there are again 2 ways to do it. So we've got the same data set, but in this case, the mean is this X bar. It's the average. So it's going to be 4. This is what they did to find the average. They did 0 plus 3 plus 5 plus 7 plus 5, all divided by 1, 2, 3, 4, 5 of them to get the average. That is 20 divided by 5 gives you a 4. Good deal. Okay, number 29. A set of exam scores with a mean score of 67 are distributed normally. So normal means it's kind of on this bell curve here, where the middle guy is the mean of 64. And an exam score of 70 has a z-score. Now, this is an important thing to note. This is the number of standard deviations. So this says at 1, 2, 3.5 standard deviations, so 3.5 times the standard deviations, you get up to 70, which is 6. Okay? So 3.5 standard deviations is 6 points. Do you see how that works? A 70 has a standard deviation. You could have a standard deviation down -1, -2, -3. So in this case, a positive 3.5 standard deviations is 6. So we just divide it by 3.5. Divide by 3.5. Calculator. Get out of the statistics stuff. Good. And we get 6 divided by 3.5 equals 1.714. There we go. Number 29 is E. All right, number 30. What is the first quartile? Now, again, this is small enough. We could do it in 2 ways. We'll do the first way by going back into the stats and editing. Let's do our list 1. We got 6, 8, 1, 10, 12, 8, 14. Good. Now we're going to go back to stat, the stat menu, go to calculations. We'll do our 1 variable stats on our list 1. And so the average would be 8.4. There's the sum of them. Okay, so we want the first quartile, and it is a 6. So it's going to be B. So the other way to do this is to put them in order. We have a 1 and a 6 and an 8 and an 8. And let me see, 1, 6, 8, 8, 10, 12, 14. 10, 12, 14. Okay, so the median would be, let me see, there are 7 of them, so we split this guy right in half. That's the median, would equal 8. And notice the calculator gave us that as well. Good. Now, this is the lower half, so we take the middle guy of the lower half, and that's our Q1, and the middle guy of this, which would be the third quartile. So really below here's 25% of the material. Here's from 25 to 50. Here's 50 to 75, and 75 all the way up to thing. So quartile 1 is 6. All right, number 31. How many ways can you line up 6 of your friends for your photo? So this is exactly what we did at the very first with 8 paintings. We could put 6 friends there. We just used 1, so we got 5 friends, 4 friends, 3 friends, 2 friends, 1 friend, which is, how many ways can you rearrange? Line up is a way of saying arrangement. 6 friends, it's 6 factorial. So 6 times 5 times 4 times 3 times 2 times 1. Probability factorial, enter, and we get 720. So number 31 is 720. So find the probability of obtaining an even number when a 6-sided die is rolled. So part over total, that's how we're going to do probability. So we have 6 options, and to get evens, That's a 2, a 4, or a 6. So there are 3 options out of 6. Well, that makes total sense. You have a 1/2 chance of getting, we have 50% probability of getting evens, 50% getting odds. Number 32 is E. What is the mean payoff expected from the probability distribution over a long enough period of time? This is interesting. Mean value is kind of what we would get to. So you'd think it was that one. They have marked 0, which means they have a very specific probability distribution that they thought was going to be out here, and it is not here. So they would normally write out some probability distribution and say, oh, your payoff is $1 here and negative $2 here and $3 there, with the probability of, I don't know, 0.2 there, a 0.6 there, and a 0.2 there. So I don't know, something like that. And then you would calculate the average to get 0, but they don't have it here, so we're throwing that problem out. All right, number 34. A fair die is rolled 60 times. What is the expected number of times a 3 will be rolled? Well, what's the probability of rolling a 3? 1/6. So 1/6 of 60 times. This is how you would expect that number of 3s to come up, which would be 10. It's really all it is the probability times the number of trials. And number 35. Final one. An experiment consists of tossing a fair coin twice. So that means, now think about what you could do. You could get a heads and a heads, or a heads and a tails, or a tails and then a head, and then a tails and a tails. So this right here, this is a 1/2 probability, 1/2. So this has a 1/4 probability, and that has a 1/4 probability, and that has a 1/4 probability, and that has a 1/4 probability, and at least 2 heads. That gives you an indication of what these problems will look like in the future. You'll be like, oh, tossing a fair coin 5 times what's the probability of at least 2 heads. We'll save the full explanation until we get to that problem. This one, that's the only way you can get at least 2 heads. So, A, that's the probability. Great.